Hey, this is Joe. In this video, we're going to do a little wiring project. What I have here is two windshield wiper motors. I have a delay box, and I have some wiring harnesses here. Originally, these windshield wiper motors were controlled independently. They each had a separate on and off switch, and they had each a separate delay switch or a delay box. And this delay box has the capability of having a 3-second delay, a 6-second delay, 8-second delay, and so on. So what I want to do is I want to be able to have one on and off switch for both motors. That on and off switch, I want to have two positions on it. One for a continuous wiper movement. The second position, I want to put it into the delay mode, where I can then control the delay with a single delay box here, as opposed to two separate on and off switches and two separate delay boxes. This wiring harness is very old, over 30 years old. The wiring is very brittle, very old. So what I want to do is I want to replace it with new wires, and I want to do some custom wiring so I can control both windshield wiper motors together and with only one delay box. As you see here, each motor has a male connector, and then there's a female connector with some wires. So we're going to join these two harnesses together, make a single harness, and then we're going to use a two-position switch. And first position is off. Second position, you have two pins that have continuity, and the second position, you have two other pins that have continuity. So that way we can wire this switch. So the first click will take you to a position where both motors are continuously operating. The second position, we put it into the delay mode, where the delay box controls the delay of the wipers. So let's get our tools, let's get some new parts, new wiring, and I'm going to show you how we're going to do this project. So an important question you may be asking is, how did I determine how these wires went together? On the back of this delay box, by the way, this is a Bosch delay box, there's a part number on the back of this delay box. I went out on Google and I Googled that part number, and I was able to come up with some wiring diagrams that explained what each wire is and where it connects to in the automobile and to the motors. So I was then able to take those wires, and then using sort of trial and error, I was able then to determine how to wire the delay box to each of the motor wiring so I could get the motors to work. And let me show you. I'm going to go ahead and add some power. I'm going to add 12 volts to the circuit, and I'm going to show you on one motor how the delay works, and then I'm going to show you how the switch and how we're going to wire the switch. So we have some 12 volts to the circuit now. The delay box is all the way to the left, so that's the off position. If I click it one click to the right, every 3 seconds, if you hear, the motor will turn on for about 3 seconds. And then if I move it one more click to the right, it's now going to go to a 6-second delay, and you get the general idea. So Google is your friend. If you can find some part numbers, you can go out and Google those part numbers, and you can hopefully find a wiring diagram to sort of point you in the right direction on how to determine the wiring of pretty much any component on an automobile. So now let me show you the switch and how we're going to wire the switch. I purchased this switch out on Amazon. It's a 3-position switch. All the way to the left is the first position. Then you have one click. Then you have a second click. Now I'm going to show you how you can determine which pin combinations work with the different positions of the switch. This switch is originally supposed to control a 2-speed windshield wiper motor, but I'm going to use it for a 2-position, or actually 3-position. We have an off position, a continuous position, and then a delay position. So I'm going to show you now how you can take a multimeter and determine those positions on the switch. Take a meter, you want to put it into continuity mode, and as you touch the leads, the meter's going to beep at you. So now what we're going to do is, by looking at this switch, I can tell I'm going to use one position for the positive coming in to the switch. So now if I touch either position here, nothing happens. So there's no continuity from this pin to these two pins. If I go one click to the left, notice the pin on the left now has continuity. So that's our first click, our first position on the switch. If I now go one more click to the left, notice no continuity with the first pin, but there is continuity on the second pin. So by taking your meter and going around and determining pin position with switch position, you can pretty much identify how these pins work and then wire the pins to your liking. So as you're doing your testing with your meter, it's a good idea to take notes here. So what I have is I have a diagram of the actual switch. They're labeled B, P, H, and L. So I've determined that one click to the right gives us continuity between pins B and L. If I go two clicks to the right, I have continuity between the pins B and H. So how I'm going to wire this switch is on one click, or B and L is going to be the continuous circuit where the windshield wiper motors are going to run all the time. Two clicks to the right, I'm going to wire the switch so that the B and H pins will go to the delay box, and then I can put the windshield wipers in a delay mode. Once I Googled the delay box and determined the pin positions, I wrote down what the wiring diagram indicated for those pin positions on the delay box. Then I was able to make some educated guesses with the wiring on each motor and how to wire those directly to the delay box. And it was pretty much straight across. The delay box indicated that brown is a ground connector, black is a ground connector, red is a positive connector, white goes to the green wire on the motor, and the yellow wire goes to the red wire on the motor. And red indicates that that's where your positive voltage is coming in. So by writing all these down, then you can make some educated guesses, and you can use your meter in order to test your ideas out. And it was actually pretty easy for me to determine what pins go to the motor and what pins go to the delay box in order to get the motors to function properly in the delay mode. And also by testing around, I know which two wires I can connect from my switch position number one, where I can get the motor to work continuously. So now what we have to do is we have to start constructing our wiring harness based on our information that we determined which wires from the delay box go to which wires on the motor. And now we can start depinning these connectors on each of the motors and making up some custom wiring, and we can build our own wiring harness. And I'm going to show you how to depin the connectors, how to make on new wire, how to make take spade connectors or crimp-on spade connectors, and then we can take those spade connectors and wiring and then rewire these connectors with new wiring and then route them appropriately to our new idea, where we're going to control both motors with one delay box and both motors in a continuous operation off the first position on the switch. Let's discuss some of the tools and materials we're going to need for this job. What we have here is a crimping tool kit made by PEBA, P-E-B-A, and what it comes with is a series of connectors, ring terminals, spade connectors, both male and female. We get a nice crimper here, a nice little toolbox, and then we have all of the different style of crimp-on connectors, male, female spade connectors. We have an assorted size of ring terminals, and we have some insulation pieces that we can put on. But because we're going to be depinning some connectors on one end, we're not going to use those insulation pieces, but on the other ends of the wire we will be crimping on some heat shrink insulation spade connectors. A depinning set. These are little very small pointed tools that you can use to depin the spade connectors from the actual wire connectors. So I'm going to show you how to use these. All these parts and materials I will put in the description of the video with links. So if you're interested in doing some wiring harness remaking, you'll have all these tools at your disposal. We also purchased some heat shrinkable connectors. These are male and female spade connectors, and these are heat shrinkable. So once you crimp them on, you can then hit them with a heat gun and then shrink them down over the ends of the wires. Again, these are a little nicer than the non-heat shrinkable ones, and they come in assorted sizes, anything from large 10 to 12 gauge, 14 to 16, and etc. So these are a nice set. Again, all these links will be put in the description. I also purchased an assorted set of wiring, but I purchased the wrong kind. I purchased the copper clad aluminum, and I don't like using that. While I was waiting for the wiring to come in, I went ahead and mounted the motors on the brackets and installed the bell cranks. And what the bell cranks do is it takes a 360-degree motor rotation, goes through the bell crank, and then switches that motion to a back and forth motion for your windshield wipers. Wiring has come in, and one thing is you always want to purchase for automobile applications multi-stranded solid copper wire. You don't want to use the copper coated aluminum wire. There's problems with that. There's a higher resistance. If you're going over long lengths of wire, you're going to have a higher resistance. That's not good. Also, the aluminum over time will start to oxidize, even though it's copper coated, and that breaks down again the resistance on the wiring, and over time you may have trouble with your circuits because the aluminum wire or aluminium, depending on which side of the pond you're on, will corrode, and again, it's not good. So spend a little bit of extra money and buy the multi-stranded solid copper wire. After I had mounted the motors, I wanted to do some amperage draw tests on the motors. When I originally had the delay switch on one motor, even at the 3-second delay, I was getting an amperage draw of 6.5 amps. When I went direct and did a continuous operation on the motors, I was only getting right around 3 amps per motor. So that's really a problem. This delay box is 30 years old, so I'm assuming what has happened is over time, again, I haven't taken this apart, what kind of circuitry is inside, but I'm assuming over time the resistance has built up, and that's what's causing the higher amperage draw. So running the windshield wiper motors right around 13 amps is just way too high and not ideal. So what I decided to do is I'm going to remove these old delay boxes and just run a continuous operation with a switch for the wiper motors. And that way I can, if I need to do any kind of a delay, I can just turn the wipers on and off manually. So again, I don't like the fact that there's such a high amperage draw. So what we're going to do is I'm still going to show you how to wire in the harness. We're only going to need 2 wires. We're going to need the red wire for the positive, and we may or may not need a grounding wire, depending on how good of a ground contact we get with these brackets. So I'm going to show you how to do that as well. When building a new wiring harness, either to replace an existing wiring harness or to customize a wiring harness, before you do anything, you want to make sure you understand how your wiring harness is going to be wired or how it was originally wired, and you want to write all that down. You don't want any confusion when you're building your wiring harness, because if you get something wrong, you run the risk of the circuit not working at all, or worse, you could short something out. So always make good detailed diagrams and or descriptions of what you're going to do. Again, this is going to be an easy one now that we don't have the delay box, but again, it's worth watching how I do this, because even on more complex wiring harnesses, the procedures and steps will be exactly the same. So what we're going to do is, here's the connectors that go into the motor, and what we're going to do is we're going to depin these usually one wire at a time, or if you want, write down the color coding of each of the wires on the connectors, and that way you know when you go to put on the new wiring and repin the connectors that you get the connections proper and the locations of the wires proper. Otherwise you will have problems with your circuit. So what we're going to do, again, without the delay box, all we need is a positive wire and possibly a ground wire. So I'm going to go ahead and show you how we're going to depin the connectors, how we're going to repin the connectors with new wire, and then I'll show you how we're going to wire in the switch, and then we can test the circuit to make sure both wipers are going to be working properly. Now again, originally these wipers were independently controlled. So what I'm going to do is I'm going to customize the harness so we can run both wipers at the same time off of one switch. So I'm going to show you how we're going to make Y connectors with some spade connectors so we can wire in both motors together and then control it from one switch. So let's get started on that. In many situations, the manufacturer of the circuitry is going to make your connectors only be able to plug in one way, and this is going to save you a lot of headache. For example, on this particular connector here, notice we have two vertical connectors on the side, we have a vertical connector on the top, and we have a horizontal connector on the bottom. So that way this connector only plugs in one way, and again, it will prevent you from having issues with putting this connector on backwards or upside down or whatever. So again, take note of these pin configurations and make sure that when you do your wiring and your depinning that you follow the pin combinations to make sure you do wire the proper wire in the circuitry according to the connector and the device that the connector plugs into. Here's the other end of the connector that is connected to the motor. Our other connector will plug into this connector on the motor, and we're interested in the red wire. But if you were doing a wiring harness where you had to make connections to all of the wiring, what you want to do is note the color of each of the wires and how they relate to the pins on the connector. So again, the best thing to do is write these wire colors down, and again, orient the wires to the pin connectors. Again, here's your vertical pin, here's your horizontal pin, and in our particular case we're interested in where the red wire is. So the red wire is on the vertical pin, the center pin is a ground pin, and on the other end of the connector it's also the center pin here. But if you look on the back side, you'll notice that there is no ground wire coming out of this connector. So in this particular situation, they're assuming that the vehicle ground is going to make the proper ground connection between the bracket of the motor and the chassis of the vehicle. And most chassis on the vehicle are grounded at some point to the negative terminal on the battery. So since we've analyzed where all the wires are and we're only interested in the red wire or the positive input and the ground, we can go ahead, and again I would write all these down, we can go ahead and depin all the wires on this connector, and then we can put in our new wire color, which is red on the vertical pin here. And what we may do is also use either the ground wire here, or what we can do is, if you look on your motor, there's a brown colored wire going right to the frame of the motor. So we can also take a ring terminal, and we can put a ring terminal here with our ground wire to this terminal, run that to ground, or in the case if our frame makes good contact to the chassis ground of the vehicle, then we don't need this terminal. But I'm going to go ahead and make up a black wire for the ground, just in case we don't get a good ground connection on the frame that the motor is mounted to. If you look at your connector, I found that a small pair of tweezers in this particular case work just as good as one of the depinning tools. If you look at your connector, right at the center on the inside, there's a little indentation or square. That's where you want to gently push. So I take one side of the tweezers and push in there. And sometimes you'll hear a little click, sometimes you won't. And you want to gently, there's a little tab on the little spade connector. What you're trying to do is push that little tab in, or sometimes on the connector there's a little plastic tab that sticks up. What you're trying to do is push that little plastic tab down so you can slide out the connector. Now when you slide out the connector, notice that there's a flat side of the connector and there's a side with two little humps. That's where your spade portion, or the male portion, slides into the female portion. So when you pull that out, you want to make sure when you put that back in it's the same way. And usually when it goes back in, it goes in with the flat side to the little indentation. And if you look at your little wire this way, there's a little tab right here, and on the back side you'll notice that that little tab bends up. So in some cases you're pushing the plastic tab out of the way inside the connector, and other times you're pushing this little brass tab down to where you can get the female spade connector out. So in this particular case, we're pushing down on this little copper or brass spade connector to be able to disconnect this female from the connector. So then we can put this off to the side. When you take the new female spade connectors, you may have to take again either your tweezers or a sharp little tool and push down on that little metal tab so it sticks out to grab onto your connector. So all we have to do now is just go around and gently, and you don't want to push too hard, you don't want to break that tab on either the female spade connector or inside the plastic connector. And there we have an empty connector, and we have all of our spaded wires out. Now what we can do is we can cut some new wire, and I'll show you how to crimp on the new female spade connectors. Then we'll go ahead and put them back in our plastic connector here. We have both of our connectors depinned. Now what we want to do is measure out some wire, the proper length, and then we can strip some wire and then put the new pins on. Now in my particular situation, the two motors are about 4 feet apart. So what I'm going to do is I'm going to cut 3 feet of wire on each side, and that way I have a little bit extra wire to work with. Also I have to determine where on the dash I want to mount my switch, and then that way I'll have a little extra wire in case I have to do some wiring to a different location. Again, we're going to run the positive wire from the ignition switch to one side of the switch, and then we're going to take the other side of the switch that is switched on, and then we're going to run that wire to both of the red pins on each of these connectors. And we're going to do that by using a Y connection, where we can take two wires and run them into, in this case, a female spade connector and connect it to the switch. So I'm going to go ahead and get some wire, measure it out 3 feet each on the red wires, and then I'm going to show you how to strip and crimp on the new spade connectors, and then we'll show you how we're going to put those connectors, the spade connectors, back into the plastic harness connector. Female spade connectors come in different sizes, so you need to identify what size your spade connectors are. And if you're purchasing from Amazon, you're more than likely going to buy import spade connectors, and they're measured in millimeters. So if you look at the end of the spade connector, they're measured from inside to inside on the pin. So get yourself your set of calipers, zero them out, and we're going to measure the inside, and we're just measuring a bit over 6 millimeters. And it turns out that one of the popular sizes for the female spade connectors is 6.3 millimeters. So that way we know when we go to put on new wire with a new female spade connector, we want to use the 6.3 millimeter female spade connectors. Now when we go to strip our new wire, let's take a look at the original older wire that was connected to this female spade connector. You notice the wire goes all the way from the two little tabs here all the way up just to the base of the spade connector. So when we strip our new wire, we want to do the same operation here. We want to make sure we have enough stripped wire to go from the base of these two bend over tabs all the way up to the base of the female spade connector. That's how you tell you're going to have good contact, and you're also going to have a good crimp to hold the wire into the spade connector. If you go too shallow, it may or may not crimp properly. If you go too long, your wire is going to creep up into the inside of the spade connector, and then you may have trouble getting the male spade portion into the female, because it may interfere with the wire sticking up into the female spade connector. Inside the box that comes with your different size spade connectors and your crimper, you want to find the 6.3 female spade. It's going to tell you the wire size, in this case 20 to 14. It's also going to tell you the crimping size of your jaws is 0.75 to 2.5. Get the manual that came with your crimpers and your spade connector kit. There's a table in here, and it tells you which jaw to use based on which connector you're using. So we're using the 6.3 male-female connector, and it has a designation of D6.3. Over on this side of the table, it gives wire gauge and jaw size. So we're using D6.3 female, and we're going to crimp 14 gauge, which is over here. So it's telling us we have to use the C jaw. And you want to make sure you read the section. It's going to tell you how much you need to strip the wire. And then what you're going to do is, it says you load the connector into the jaws of the crimper. You're going to crimp down to the first click. Then you can insert the wire into the crimper and you can then fully crimp. And there's an adjustment for how tight you want the crimp to be. There's a little rotating wheel on the crimpers that you can adjust for that. And one thing it does indicate is that when you strip the wire, the end portion or the insulation portion will actually be inserted into the first part of the tab. So your insulation will come up to these longer tabs, and then the uninsulated portion of the wire is going to come in and stop right at the base of the spade connector. And there is an image here that shows you what that stripped wire will look like when it's inserted into the spade connector. So make sure you review the pliers, because it's not as simple as it looks. So as it said in the manual, we want to load the connector into the crimper, and if you look very closely on this side, the tabs of the connector are going to be flush with the edge of the jaws. So then if you look at the other side, again, the tabs are going to be flush with the jaws. So now it says you then take the wire, insert it into the jaws and the connector, and then you can squeeze fully to crimp the wire onto the connector. Now we've inserted the wire into the jaws, and now we're going to perform the crimp. And as you see, we have the insulated portion underneath the wider tabs, and then the bare wire or the stripped insulation under the smaller tabs. And the wire is now crimped onto the connector. After you crimp your wires, take your connector, make sure we find the vertical connector. We want to put that in, and you'll feel it go in past the little tab, and make sure that's crimped properly. Now we can take that wire and put it on the other motor male pins, and then we can, I'll show you how to wire up the other side with a Y connector. When you want to do a Y connector, or just take two wires and put them into one female spade connector, these are 14 gauge wires, so you want to get the next size larger female spade connector. What I like to do is solder the ends of the wire, twist them together, then solder them. Then you can insert them in to, and I like to use heat shrink spade connectors. Put them in, crimp them, and then heat shrink the back side, so you'll get a nice good connection. And that way we can take this one spade connector and put it into our switch, and we can control both motors off of a single switch. We have both motors connected to the switch with the 10 to 12 gauge female spade connector. We have 12 volts coming in to the switch. We have both motors grounded to the base of the motor. So let's now go ahead and turn the switch to on. And you see we're pulling about just a little over 6 amps on both motors, and we're running, as you can see, the bell cranks are turning on both motors. So this is a continuous operation. If we want to pause, we just turn the motors off, turn the motors back on. And this is a very simple way to create a custom harness, in our case to run both motors continuously off of one switch. Hope you enjoyed this video, and we'll see you next time.